morning. Welcome to business math class. We have just finished passing out the last packet of notes that you're going to have while we're students and teachers together. We have one last module. It covers compound interest, and it's chapter 7 and 8 in your textbook. When this is done, we'll have a test over this, and we will have completed all of the 5 topics that we need to cover. And so you've got notes here for chapter 7 and chapter 8. Compound interest is what we're going to talk about next, and most students find it very, very interesting. There is no way that you can complete what we're going to do in this next section without a financial calculator. The financial calculator that I'm going to be using is the Texas Instruments BA 35. It was on the syllabus as being a required supplemental piece of boy, my mind's not doing too well this morning. Equipment that you will need. If you choose not to use the BA 35, then a supply. That was the word I was looking for, supply. If you choose not to do that, there are many financial calculators, but you'll be responsible for figuring out how yours works, okay? People in the Math Resource Center are good with lots of these, but that's the one I'll be demonstrating with, okay? Are there questions about the financial calculator? Okay. Today what we're going to do is figure out how we would calculate compound interest manually. What we like to do, excuse me? Oh, you need the notes, I'm sorry. Does anyone else not have the notes? When you got here we were talking about other things. And these are some worksheets that we're going to deal with tomorrow. But I like to sort of get things, passed out. I think it's very important when we introduce something that's a new topic to tie it to some prior knowledge that you have. What we're going to do today is try to tie some prior knowledge to some new learning that we're going to be doing over the next couple of days. So what we're going to do is, although we're going to use our financial calculator in order to make these compound interest calculations, I think it's important that you understand how you would manually do that if you did not have a financial calculator. So to begin with, we're just going to be doing some calculations without using our financial calculator capabilities, and then I'll show you by the end of class how you would get exactly the same answer putting it into a financial calculator. Is that okay? So we're going to sort of tie old learning to new learning. Okay. So on the top of your notes, 7.1, it says compound interest. First, we're going to just do a simple interest problem that is for review only. Okay, should tie very nicely to what we just finished. It said, Matt deposits $1,000 into a savings account. It earns 10% simple interest. So this is last section, right, chapter 6. How much does he have in his account at the end of 4 years? How much interest does he earn? $400. So how much would he have in his account at the end of the time? He would have earned $400 worth of interest. He would have had the original $1,000 he deposited, the $400 worth of interest, and his account balance would have been $1,400. Simple interest. Okay? Is that all right? In this chapter, we're going to discuss compound interest, however. Compound interest is used on home loans, savings accounts, credit card accounts, retirement plans. It is important that you understand that compound interest is nothing more than the repeated use of simple interest. So it's simple interest used over and over and over, okay? New problem. Matt deposits. I'm going to go out a ways on this so we can see what we're doing. Am I on there? Yeah. Matt deposits $1,000 in a savings account. Same $1,000, same Matt, different bank. 10% interest. This time it is compounded annually. How much would Matt have in his account at the end of 4 years? This would be a very common thing for you to do. Put $1,000 in a bank account and have the interest be compounded. And the compounding periods can be over different amounts of time. Different numbers of times per year. Annually says it is compounded. How many times a year? Once. Good. If it's compounded semi-annually, that would mean every 6 months. It would be compounded twice a year. If money is compounded quarterly, it would be compounded every 3 months, or it would be compounded 4 times a year. Interest is often compounded monthly, which would be 12 times a year, and interest can be compounded daily, which would be 365 times a year, right? So compound interest can be for different lengths of time. We're saying this one's annual to keep it kind of clean and to make the numbers neat, okay? So how much does he have at the end of 4 years? Well, let's first figure out how much he has at the end of the first year. During period 1, at the end of the first year, he had $1,000. The interest that he earned would be $100. I get that by taking I equal PRT. $1,000, 10% interest, the time is 1 year. Is that all right? At the end of the first year, Matt would have $1,100 in his account. Simple interest, one time. Questions on that one? Okay, end of the second year. The principal that was in Matt's account at the beginning of the second year is $1,100. How much interest would Matt earn during the second year? Once again, it would be I equal PRT. Principal is $1,100. Rate is 10%. Time is 1 year. The second year, he would earn $110. I add that interest to the principal. At the end of the second year, Matt would have $1,210. Does everyone see that? How come the interest is more in the second year? The principal was higher. What compound interest is interest paid on prior interest earned, more than just the original principal. So to begin with, he had interest on $1,000. During the second year, he had interest on $1,100. That additional $100 is drawing interest, and that $100 that's drawing interest is the interest from the year before, interest on interest. Is that all right? Third year. Principal is now $210. Interest is I equal PRT. Principal is $1,210. Rate is 10%. Time is 1 year. During the third year, Matt would have earned $121. The difference between the 110 and the 121 is the interest on the prior interest. Ending balance at the end of 3 years is $1,331. Is that making sense? The repeated use of simple interest is all that compound interest is. End of the fourth year. Going into the beginning of the fourth year, the principal is $1,331. I once again calculate interest. It's I equal PRT. The principal keeps changing. The principal keeps increasing. Therefore, the amount of interest earned each year keeps increasing. At the end of the fourth year, Matt will have earned interest for that year alone of $1,333.10, giving him a balance of $1,464.10. Okay? Wow. Up here he had $1,400 simple interest in the original problem, the review, the one, let's tie it to some prior learning. Compound interest, Matt has $1,464.10. The reason for the additional $64.10 is the compounding of interest. He got paid interest on prior interest. Is that all right? It says, explain the difference in the account balances at the end of 4 years. In example 2, interest was paid on prior interest. If interest is compounded, you earn more interest than simple interest. Does that make sense? I mean, do you see the numbers and why it's working? Okay. New problem. Matt's got a sister named Mary. She goes to another bank. She's got $1,000. She puts it in a savings account. It earns 10% interest, just like Matt's money. but it's compounded semi-annually. Compounded semi-annually says Mary is getting paid interest twice a year. So every 6 months, Mary earns interest. How much does she have in her account at the end of 2 years? Let's remember that at the end of 2 years, right here, Matt has $1,210. Let's see how Mary turns out with her $1,000 at the end of 2 years. Here we go. In the first compounding period, I need to widen just a little bit here. That's at the end of 6 months. Her principal is the original $1,000. Interest is equal to PRT. $1,000, the rate is 10%, but at the end of the first compounding period, how much time has passed? Semi-annually says 6 months, so it's 6 divided by 12. She would have earned $50 in the first 6 months. Are you with me? So the end of period 1 for her is not the end of the first year. It's at the end of the first 6 months, the first compounding period. Mary would then have $1,050 in her account at the end of the first 6 months. And does everyone see what we're using for time? For time, we're using 6 divided by 12. Okay. Here we go. Second compounding period, which is actually the end of the first year. Is that all right? Going into that compounding period, I'm running out of room here. Let me scoot up. At the end of that compounding period, she would have a principal of $1,050. When I calculate the interest, Mary would earn $5,250. Does everyone see what I'm using for numbers? P in that compounding period is 1050. Rate is 10%, but time is 6 divided by 12. It's only half a year, right? So at the end of the first year, Mary has $1,102.50. How much did Matt have at the end of the first year? No, at the end of the first year. See, it takes 2 compounding periods for Mary to be at the end of her first year because it's semi-annually. So he had $1,100. She's got $1,102.50. How come? Compound interest. She earned interest on interest. What does that kind of tell you about this compounding? The more often it compounds, the more interest you make. That's right. The more interest is earned. Is that kind of making sense? Okay, we need to do then the third compounding and the fourth compounding period for Mary's money. And again, when we get done to the fourth compounding period, we will only be at the end of the second year because her money is compounded every 6 months, semi-annually, right? Third compounding period, $1,102.50 is the principal. We're using R of 10, time of 6 divided by 12. She would earn $55.13. The difference is interest keeps getting larger during every compounding period. Mary's balance at the end of the third compounding period is $1,157.63. Yeah. Fourth compounding period then will get us to the end of the second year with Mary. You got a question? You okay?
She didn't look where the 2 years was at.
Ah, okay. Since it's semi-annually, it takes two compounding periods to make a year. Yeah? Are you seeing how complicated if we have a loan or something in for 30 years compounded monthly this would be? We would have to make 360 of these calculations. Yes. Which is why you suddenly go, ooh, less than $20. I can buy a financial calculator and do all of this. Yeah. Compound interest gets complicated, because it would take giant ledger sheets in order to do it. Right. So how much money does Mary have at the end of 2 years? Which would be the end of 4 compounding periods. I've got that she'd have $1,215.51. How much did Matt have compounded annually at the end of 2 years? 1210. Mary's got 12, 15, 51. Yeah? So, question is, top of the next page. What is Matt's account balance at the end of 2 years? What is Mary's account balance at the end of 2 years? 2 compounding periods for Matt, 4 compounding periods for Mary. Does everyone understand where we're coming up with those? Good. What is the difference? Explain it. Matt has a total of $1,210. Mary has $1,215.51. What is the difference? She had more compounding periods. The more often you compound, if you're using the same rate, the more often you compound, the more money is earned by the account. So she got an extra $5.51 simply by having it compounded. Now, do we want to do 2 years compounded monthly or daily, manually? No. I mean, 2 years compounded monthly would be making 24 of those calculations, bringing that balance back and forth. Yeah, they get kind of ugly kind of quick. Yeah. All right. We're saying right here, in the next section, you will use your financial calculator, and I stress the word your in that because you are really responsible for providing your own. You need to have it on the test. You need to have it on the final. We don't provide a financial calculator for you. Where did somebody buy theirs? How much? 20. Where did somebody else find it besides Office Depot? College bookstore.
They're $19.95 there, and they're $19.95 here at the bookstore, so college.
Okay, she's saying $19.95 everywhere. Anybody find a better deal any place? And I'm sure that Target, any office supply place and bookstores have them. And they operate completely different than a scientific calculator. A scientific calculator won't have the stuff you need. It is important that you become familiar with the variables that you put into your financial calculator and that you recognize them and you recognize, what we're going to call each thing, okay? So, in your financial calculator, we're going to have several different new terms. Let me get in here. PV, and it stands for present value. Generally, in every problem that we deal with, that's going to be the starting amount. Is that all right? For example, when we were dealing with Matt, the starting amount was $1,000. Does that make sense? Okay. Future value, that would be the ending amount. How much you have at the end of a certain period of time. Yeah? And the number of times you would have to use the I equal PRT formula in a table. When Matt's interest for 4 years was compounded annually, how many times did we need to use the interest formula? Compounded annually, 4 years, we would have had to have made 4 calculations. Good. Mary, compounded semi-annually for 2 years. We still had to use 2 years, 2 compounding periods, right? And I've been using the example. What if it was compounded monthly for 2 years? What would N be? Compounded monthly, it'd be 24. Good. What if Matt was compounded monthly for 4 years? 48. Okay, N is the number of times you would have to use the simple interest formula in order to complete these calculations. So that's what we're going to tell it. How many times, calculator, are you going to use that internally to make those calculations? And it's going to do it for you, all for $20. The percent of interest paid each time interest is compounded. Okay? Let's talk about that one for a minute. When Matt got paid 10% interest annually, each time he got paid interest, he got paid 10%. Yeah, what changed was the principal coming in was higher. Is that making sense? When Mary got paid semi-annually, what actually happened is she was earning 10% per year, compounded semi-annually. So how much do you think she was making each compounding period? How much? But she was only making it semi-annually, so she really wasn't getting 10% each time. She was actually getting 5% the first time and then the other 5% the second time. Is that making sense? So how we're going to come up with our, what it's called percent of interest, is we're going to take the interest rate that you're getting paid, for example 10%, dividing it by the number of times that it's compounded annually, and that'll give you the percent that's being paid each time.
Is that 4 times? Or?
Excuse me?
So on Mary would be 8 times, wouldn't it?
But okay, listen to my story. Mary's getting paid 10% per year. It's getting compounded twice a year, semi-annually. So you just take 10 and divide it by 2. Are you with me? And that would be 5%.
So on maths, would it be divided by 1?
Yes, it would. What if one of them was getting paid 10% compounded monthly? It'd be divided by 12. 10 divided by 12, that's right. What if it was compounded?
It would be just 10, it wouldn't be 0.10?
Well, it'd be 0.10. Well, it's 10 divided by 12. It would be 0.8333%. We're going to enter these as percents. We're not going to enter them as decimals. Okay. When you're asking me, is it 0.10 or is it 10? We're going to use 10 because we're going to be talking about percents. Right. So we're not changing that to 0.10, and then we're not changing it to decimals, right? So if we're talking about 6%, we're going to talk about 6.
Why do we do his by 1?
Because he was paid annually. So it was 4% each time. Okay, let me change it to make the numbers simpler. 12% compounded monthly. Cassandra, you would then get 1% each time. Is that all right? Okay. Last thing is payment. We are going to not talk about payments until Chapter 8. Payments is the amount of a regular payment. It can be a withdrawal or a deposit into our account. In our stories so far with Matt and Mary, they put money in at the very beginning, they had money at the end. Under no time did we say, and every month Matt adds another $50. Are you with me? And we're not going to consider payments during any part of Chapter 7. We're going to keep them clean. And then, which we did in simple interest, and then in the end, remember we made partial payments? We're going to make partial payments in the second chapter when we talk about compound interest also. Okay? If you look at your financial calculator, you will see that N, percent I, PV, payment, and FV are all right there. Is that making sense? And that's what you need to make sure your calculator has. If you're choosing to use the TI-83, then there's a program that you can get into, and they've got instructions in the Math Resource Center on how to use it. But what we're looking for on the financial calculator is those numbers. What we're going to be doing is figuring out what those numbers are, and then what we're going to do is load them into our financial calculator. This button stands for compute, and we're going to be computing, yes? So how many total entries are there? 1, 2, 3, 4, 5. Anytime you have 4 of those, you can compute the 5th one. Is that all right? We're going to be giving you enough information. You know when we did interest, I equal PRT? As long as you had 3 of those variables, you could come up with the 4th one. In this one, we have 5 variables, and anytime you have 4 of them, you can come up with the 5th one. We can compute any one of those if we have the other 4. Okay? So, question, In problem number 2 and 4 above, the Matt problem and the Mary problem, we want to identify PV, FV, N, and %I. So what we're going to do is talk about, first of all, problem number 2, which is Matt. Whoops. In Matt's problem, his present value was the starting amount he had in his account. It was $1,000. FV was what we were looking for, the future value. The number of times we needed to use the interest formula was the 4 years that he deposited it times 1, because it was compounded annually. And the %I was 10, or 10 divided by 1. Okay? We're not going to load those in right this minute. We're going to do that in a second. We just need to identify those at this moment. And then we're going to come down here and we're going to talk about Mary. Present value for Mary was also $1,000. That was the starting amount. That's how much Mary put in her account originally. Again, we were looking for future value. We were looking for the account balance at the end of a certain time. For Mary, the number of compounding periods, if we were going to do it for 4 years, would have been 8. If we were using it for 2 years, it would be 4. Does that make sense? However many compounding periods, yes. And then it says, what was the %I? How much was Mary getting paid in interest every compounding period? 10% annually, compounded semi-annually. It's 10 divided by 2 is 5, okay? Is that all right? What they're going to do in the homework is yes? Oh, because I'm going to stick that in a cat. You're saying it was 2 years? Okay. In the actual story, we're going to stick them in. Yeah, okay. In the story problem, I guess, we really did have 4 because it was 2 times 2. What I'm going to have you do is calculate it and see how much she's going to have. I was probably thinking something different than I was saying. You're right. In the problem itself, I had 2 years semi-annually, which is 4. Draw a line through that. What I'm going to do in a minute is have you calculate conveniently her balance and his balance in your calculator at the end of the same time, which is 4 years. So, yeah.
Okay, so the 4 times 2 you would be showing would be like quarterly?
No, it would be 4 years twice a year.
4 years twice a year.
Yeah, 4 years semi-annually. Okay. In the problems that you're going to do, on number 1 and number 3, you need to make tables just like we made for Matt and Mary. Those long, yucky, compounding tables, right? After that, it's saying identify the variables. Now, what I've given you is a sheet, yeah? Are you with me? That's got those variables across the top of it. You are more than welcome, and I'll give you more of these, to just write down the page number and then, 1, 3, well, we're doing 1 and 3 as a table, but then as you're doing these problems, you can just use this for your homework, okay? And I'll show you what this looks like.
Are you going to show us how to do this?
I'm going to. Just give me a minute.
Oh, yeah.
And you see that what we've got here is N, %I, payment. I've guaranteed you that 0 for right now. PV, FV. Just put a question mark up in the corner of the one we're looking for. And then when you get the answer, you can plug it in, and that way I'll know that you knew what you were looking for originally. These are some other things that we're going to talk about later on when we're making payments. If we haven't talked about them today, there are some problems on here, some numbers on here yet that you can ignore. And as we keep going through the process, by the end you'll know what you're going to enter in all of these columns. At this point, N, %I, payment is going to be 0 for everything you're doing. FV is the ending balance. PV is the beginning balance. FV is the ending balance. There's your 5. As we add bells and whistles to these stories, we're going to be using some of these other columns, but you can do all of your homework on these because there is no work to show. And I used to say to students, I want to see your homework and I want to know what you entered. And I would get something different from everybody, and it was really hard, and then they'd go, ooh, I don't remember what, people would write them down and not tell me what they were, and then couldn't re-enter them and get those. It's very hard to kind of remember what you were doing 3 days ago. So if you'll just use these sheets for your homework, it'll really help you be consistent. Okay? Then I'm going to show you, and don't write these down, but what we're going to do then from then on, if you'll look at the next, that's the next page, look at tomorrow. All those boxes are going to be on there. We're going to be filling them out together. You're just going to be able to go home, fill out the sheet, enter them in your calculator. Does that make sense? And we're going to do it. So, and on the test, I'm just going to provide these boxes, and you're showing me the work will be you showing me what you entered. Okay? So you'll be using these worksheets for your homework. You're more than welcome to Xerox more of them, yourself, or I'll try to have some extra ones for you. But I really like the worksheets, and those will be on the handouts, and those will be on the test. Okay. So take your calculator. We're going to be looking at these numbers right here that we dealt with Matt. We've got, and if you just give me a minute, I will get going here. Hold on. I'm trying to get so I've got everything on here. The first thing you need to do is turn your calculator on, obviously. Let me see if this shows better if I don't have that. No, that doesn't make it any better. So let me put that light back on. It works better right there. You need to make sure that financial is on in mode, and here's the mode button. Do you see there's nothing? There's financial and there's statistics. For you to be able to do these, you need to have FIN right there. Has everyone got their calculator in FIN mode, financial mode? Okay, let's look at Matt. We're going to say that Matt started out with $1,000. Hold on, I need you to be able to see everything we're doing here. So you need to enter 1,000. 1, 0, 0, 0, there's 1,000, and all you do to load it in, where does it go? PV. Cool. Load it into PV. Yes? Future value is, we don't know, so don't worry about it. N is 4. So enter 4 in your calculator. That just loads it into N. It's like there is a piece of memory back there, and you enter what you want in your calculator, and then you say, load it in. Okay? What do we know about %I? 10. And we load it in. Yes? What do we know about payment? Well, I told you already it's 0. Yeah? Okay, so right now, we know that we have in 4. We have in loaded into %I. I'm not saying, when I say in, I'm saying IN, not in. Are you with me? 10. We know that we have 0 in payment, 1,000 in PV. There's a compute button. So we say compute, and we're computing FV. Now go back and look and see. Is that what we got? Matt, the end of 4 years? Huh? Which do you prefer? Okay. Now, don't clear. Are you with me? Oh, you've already cleared?
Well, I didn't get that answer.
Okay. Very good. Marilyn, stop. Don't clear.
I did clear it because I didn't get that answer.
Okay. Next time, don't clear. Let me show you what we can do. Are you with me? This is the reason I keep saying, don't clear. You can hit recall down here. You see recall? I'm going to recall in, and it says, yep, in I have 4, just like I thought. Recall %I. Yep, I have 10 in %I, just like I thought. Recall PV. I have 1,000, just like I thought. Recall payment, 0, just like I thought.
Don't enter 0 in payment, does it automatically assume it's 0?
Well, what we needed to do to begin with is clear to make sure there wasn't something there from before. If we clear to begin with, then all 5 of those are 0. Okay. If you don't hit clear, then you need to enter a 0 to make sure. Yeah, right. I have a tendency to go ahead and enter the 0. Okay. But as long as you clear twice first, then it will get rid of those. Okay, let's do it one more time. 4, put it in. 10, load it into %I. And again, it's not a decimal, it's a percent. We loaded 1,000 into PV. And then we loaded 0 into payment. And then you come up here and you say compute FV. Did it work that time? Yep. Okay. And if you're not getting the right answer, don't clear. Go.
1,000
Okay, then take a minute. Here's what I want you to do. Recall and hit in.
I did. I checked them all. It's 4. Recall, my percent is 0.1.
No, it has to be entered as a percent. 10.
That's okay. That's what I'm
Yeah. And as we go through these, and
clear one of them. You don't have to clear it. Just put 10 in front.
just put 10 and load it. It'll replace it. It just overwrites.
Okay.
Did it work this time? The nicest thing about all of this when you get done, when you get an answer and you're on the test, my suggestion is you look at the listing of things you thought you entered, and then you recall it. As you write down your answer, recall the other memory pieces to see that you entered what you thought you entered. Did it work that time? Percent is a percent. Yeah, okay. Now, this is all very nice. Yeah, that's cool. We can go ahead and do Mary. We do not have to clear the whole thing. If we choose to, we can hit clear and we can clear the whole thing. But if we look, PV doesn't change. With me? Number of compounding periods doesn't change. It's 4. The only thing that changes is the percent that she is paid each compounding period. So I can just say, ooh, Mary got paid 5% every compounding period. Load that in. Yeah, compute her future value. There's Mary's balance. And does that correspond to what we did when we made a table? Yes, it does. Now, my next thing is, this is where I was headed. What if I wanted to know what was Mary's balance at the end of 4 years? How did it compare to Matt's balance at the end of 4 years? She got paid. She earned interest semi-annually. That's right. That's where I'm heading. For 4 years, compounded semi-annually. I'd go, and look at what we can do here. 4 times 2 equal 8. I can make a calculation. Come and load that into the number of compounding periods I'm interested in for Mary. I don't even have to make them a calculation manually. I can go 4 times 2 equal 8. Then I can compute future value and say, at the end of 4 years, which is 8 compounding periods for Mary, she would have $1,477.46. How much did Matt have? That's when you can kind of flip back through the pages and say, ooh, Matt had $1,464. She had whoa, my lights are bright. $1,477. The reason she had something like $13 more than him was the extra compounding periods, yeah? Which then starts making it very easy to say, ooh, what if they had a brother named Kevin and he put his $1,000 in the bank and it got compounded quarterly, monthly, daily? Which one? Pick one. Daily. We would say 4 years daily. Okay, new person, 4 years daily. I don't even have to get out a piece of paper. I can go 4 times 365 equal, that would be 1,460 compounding periods, yes. I would load that into N. Now let's talk this over. If they got paid daily, how would I figure out what interest rate they got paid if it was 10% annually?
10 divided by 365.
Thank you. 10 divided by 365 equal, and again, you don't have to write that down. Just load it into your percentage. So we have got somebody that, now let's think about it, recall, loaded $1,000 into an account, right? Recall, they're going to get paid interest 1,460 times, which is 4 years daily, 4 times 365. They're going to get paid that much interest, which is 10 divided by 365 per compounding period. recall payments of nothing, next chapter, we can compute their future value, and daily, they'd have $1,491, and that makes kind of sense. It's more money than semi-annually, which is more money than annually, and so that would be a daily compounding. So if you just think the process through, but now, under no circumstances do you need to calculate any of the monies in 7.1. Are you with me? All it's asking you to do is identify variables. In 1 and 3, you need to make a table. The rest of them are just identify variables. They're not even asking you to, you can just put a question mark by what you're looking for. What we're going to do then is lots and lots of story problems, and we're going to be calculating, making these tables, loading them into the calculator and letting it do all of the work for us. Okay, we will see you on Wednesday.